Hi everyone. For the next several weeks in the class, we're going to be comparing two groups, and specifically the means of two populations. Before delving into the statistics of these comparisons, however, I thought I'd start out with a real-world example. The picture on this page is of a plant, a cement plant, out in the western U.S. Several years ago, the plant proposed to start powering itself, essentially generating its energy, with TDF, tire-derived fuel. Now, tire-derived fuel doesn't mean they just grab tires and throw them into the incinerator. The tires are ground up and they're combined with other combustibles, and through that they are burned to produce energy. The local population was a little concerned, however. Tires, through the process of running, pick up a lot of toxins. When they're burned, are those toxins going to be released into the air and into the water? So the general setup is this. You've got a plant, and here's its smokestack, and it has emissions, so the emissions from burning the tires are blowing out. The prevailing winds are blowing from west to east, and so you've got two natural groups. You've got a group upwind, and you've got a group downwind. And in general, the question is there more pollution downwind than there is upwind? So here is some terminology for a comparison of two groups. For two groups, you actually have two populations. In the cement example, the population would be, for example, all the soil that's upwind and all the soil that's downwind. So you've got two groups that you're comparing, the populations. Now, obviously, you can't test all of the soil downwind and all the soil upwind, so you take a sample of soil upwind and a sample of soil downwind. So from these populations, you draw samples. The population means that you're interested in we'll call mu1 and mu2. From the samples, you draw some sample size. From sample 1, samples n1. From that sample, you've got a sample mean x bar 1, and that has a sample standard deviation s1. The same thing for sample 2. Sample 2 has a sample size of n2, a sample mean of x bar 2, a sample standard deviation of s2. And the general question you're interested in, I'd like to compare mean 1 and mean 2. So mu1, does it equal mu2? Or is the average, mu1 in this case might be the average amount of mercury in the soil. Or is there a difference? Is the average amount in population 1 greater than the average amount in population 2? Is it less than? Are they not equal to? So that's the general setup of how we are comparing two groups. Again, we'll get into the details in some later videos. But to do these comparisons, there's really two principal methods. Okay? And the methods depend on how you're collecting your samples. The first method is called independent samples. So when you're sort of examining a problem, the first thing you want to ask yourself is what's the nature of the populations and the samples. Keep in mind, anytime you're comparing two groups, you've got the same data value from each group. In the pollution example, would be the amount of mercury downwind, the amount of mercury upwind. So you're comparing the same measure in the two groups. Independent samples are essentially you've got two groups, and the definition of independent samples, that two samples are independent if the selection of the objects from one population is unrelated to or does not impact the selection of objects from the other population. So you've got two populations in this figure. You draw a sample from population 1, so there's sample 1, and you draw a sample from population 2, sample 2. The selection of the samples are completely unrelated. The other type of sample are called dependent samples. And dependent samples are a very special type of sample. They occur in certain situations. So here's the definition of dependent samples. For dependent samples, two samples are dependent if the selection of an object from one population results in the selection of an object from the other population, forming, and here's the key, matched pairs of objects. What I'm going to ask you to do, if you think that two samples are dependent, I'm going to ask you to tell me what's being compared. And we'll see an example of that in just a minute. An example of dependent samples, a friend of mine actually conducted a study on gender bias in salaries. And rather than just collecting salaries of women and salaries of men, you want to make sure that the comparisons are sort of the same, they're equal. So maybe in company one, the individual examined salaries of men and salaries of women. And say that was P&G, Procter & Gamble. In sample 2 might be a McDonald's franchise, salaries of men and salaries of women in comparable positions. You know, the P&G executives wouldn't necessarily be expected to have the same salary as the McDonald's franchise owner. So what you try to do is you try to pair up the samples, meaning that you want to make sure in your comparison that you're comparing the man in the P&G salary with the woman in P&G salary, the man in the McDonald's franchise with the woman in the McDonald's franchise. Since your dependent samples, you make an effort to try to compare, as I call it, apples to apples. All right, so what I'm going to ask you to do in some problems is, when you look at a problem, identify are the samples dependent or independent. And here are two examples. All right, so in example 1, I've got 36 students in section A of a multi-section class. I've got 32 students in section B. Okay, section A is a face-to-face class. Section B uses only online methods. So the question that one might ask is there a learning difference, face-to-face versus online? Okay, so at the end of the semester, the students in each section complete a common final exam. And then the scores for section A are compared to the scores for section B. So what type of samples are these? These are independent. You've got a group of students from section A. Now you might say, well, you selected all the students from section A. But the 36 students from section A were a sample of all the students that use face-to-face methods. The 32 students from sample B are a sample of all the students that use online methods. Selecting students for section A does not impact the selection of students for section B. So the samples of scores are independent because, and here's the reason, which I'll ask you for, the selection of students for the face-to-face section from all face-to-face learners, and the selection of the online students from all online learners are unrelated. That's the definition of independent. Here's our second example. Again, independent or dependent. At the beginning of the semester, students randomly select 50 students enrolled in a course and give them a problem-solving test. Problem-solving pretest, excuse me. At the end of the semester, having completed the course, the same group of 50 students complete a problem-solving post-test. To determine if the class improves problem-solving abilities, the pretest and the post-test, and here's the key, for each student are compared. So these samples, the samples of pretest and post-test scores, are dependent because, and the key is that last sentence, for each student, the score on the pretest is compared to the score on the post-test. One student may come in with a high problem-solving score. Okay, so student 1 may have a high score. Student 2 may come in with a lower score. You want to compare the growth of student 1 to student 1. So pretest and post-test. For student 1, you want to compare his or her pre-test and post-test. For student 2, his or her pre-test and post-test. You don't want to compare the pre-test of student 1 to the post-test of student 2. There's no reason to think they'd be related. So, why are these dependent? For each student, the score on the pre-test is compared to the score on the post-test. One key marker you might notice here for independent and dependent. Let me look back at the independent example. Notice you had different numbers of students. In one group you had 36, in the other group you had 32. Well, you cannot form partners. You cannot form pairs with a 36 and 32. Essentially, 4 students in section A would have no partner from section B. Now, the dependent, notice you've got 50 post-test and 50 pre-test, each drawn from the same student. That's why they'd be naturally paired up. Now, you can have dependent samples with the same numbers. Again, if you just select salaries of 30 women in one region of the country and salaries of 30 women in the other region of the country, and just compare average salaries, you're not trying to partner those up. You're not trying to pair up the salaries in one region with the salaries in the other. You're just looking at it as a whole. Anyways, that's an overview of independent and dependent samples. And the next videos, we're going to examine how do you actually examine, how do you make, draw inferences about these samples.